Assalamualaikum warahmatullahi wabarakatuh. So today we're going to discuss on uniform circular motion. Right. So if you notice when you are moving in a circular motion, for example, let's say you are in a car that moving in a circular motion, even though that the speed of the car is moving in constant speed, all right, around the circle. Okay, you will feel some force. All right, usually your body, uh, when you are a passenger in the car, okay, will be will have an effect of inertia, where your body will tend to move outward, okay, outward, when the car moving in a circle. All right, and that will happen every time when the object ataupun the car tu is moving in a circle, despite whether the car is moving in a constant velocity, or also when the car is moving in acceleration. Okay, but what interesting is that when the car is moving in constant speed, you will still feel the inertia, okay, where the inertia basically is a proof that there is a force exists during the circular motion, and uh, the force can only exist, okay, when there is an acceleration, okay, because force and acceleration are interconnected, right? So why is this happen, right? If you look into the equation of acceleration, basically acceleration exists when we have a change in speed or velocity. Okay, when we have a change in velocity, then we will have an acceleration, right? And velocity can change, right, in two ways. Okay, one is it can change in terms of magnitude. Okay, when we have a change in magnitude, which mean the value of the velocity either increase or decrease, okay, then we will have a change in velocity. Okay, beside the values or the magnitude of the velocity, the change in velocity can also occur when we have a change in direction. Okay, when we have a change in direction, we will also have a change in velocity, which lead to an acceleration. And what occur in this motion is that we have a change in direction, because you see, when as the object, let's say, move in a circle, let's say from point A to point B, the direction of the velocity changes. Okay, let's say at location of A, we have velocity, right, which is directed in vi. Okay, so this is the direction of vi at velocity at point A, and then as the car reach point B, right, the magnitude of v is still the same. Okay, vf, the magnitude of vf and vi is still the same, but the direction of vf is different. Okay, we can see that direction of vi is like this. Okay, and the difference between two directions can be shown in this diagram, where vi is like this, right, and then vf is like this. So these two will produce delta v. Okay, so delta v then, according to previous equation, okay, produce acceleration. Okay, and the acceleration, okay, in that motion will be directed as delta v, which is in this direction. Okay, so if we examine further the diagram, the triangle here, okay, we can see that these two triangles are related. Okay, so the triangle between V, right, VI and VF, delta V, and also the triangle of R, okay, R initial, R final, and also delta R. right, is related where angle between these two are the same. Okay, and since the angle are the same, we can rewrite the equation, right? Or we can analyze the triangle, right, in terms of delta v over v. All right, so delta v over v, all right, whether delta vi or vf is the same as delta r over r. Okay, so delta v over v, right, is equals to delta r over r, since triangle 2 is the same. Right, so delta v over v equals to delta r over r, right? And acceleration, as we know, is equals to delta v over delta t. Okay, and delta v here, all right, can be written as from here, all right? So taking this v to this side, okay, so we can rewrite delta v here as v delta r over r delta t. Okay, and since A is equals to delta V over delta T, and delta V itself is VR over R, right? V delta R over R, so the whole equation become like this. All right, and dr dt ni, as we analyzed earlier, right, is equals to V, right? So this equation is equals to V. Okay, so we can rewrite A, or in this case is the centripetal acceleration, all right, equals to V square over R. All right, so the inertia that you feel just now due to the motion of object in circular motion, okay, is the result of the centripetal acceleration occur when the car moving in rotation, okay, or in circular motion. All right, when we have a force, all right, usually force is will produce inertia, can, for example, when you have a change, right, when you have a force that cause an object change its system from from still, kan, to moving, so your body will feel inertia, kan. Let's say you are in the car and the car change its system from not moving to moving, you will feel inertia where your body will move backward, kan. And if let's say we have a change when your car change its system, kan, from moving to stop, okay, due to force itself, okay, due to force, and so you will feel an inertia where your body will tend to move forward. Okay, so same goes in this example, right? When the car is moving in a circular motion, so there will be an centripetal acceleration, where centripetal acceleration is directed toward the center. All right. Your body will feel inertia, okay, where it will move out. It will move in a in opposite direction of the centripetal acceleration. So in this case, your body will move outward. All right. And centripetal acceleration, as we have defined just now, is equals to v square over r. All right. So this is your first equation in rotational motion. All right, centripetal acceleration. And so centripetal acceleration, all right, is quite different from a normal acceleration, because normally acceleration will only produce or will only occur when we have a change in velocity. Okay. Uh, but centripetal acceleration will exist as long as you move in a circular motion. All right, whether your object or your car just now is moving in a constant speed or in acceleration itself, right? Both type of motion, as long as it is moved in a circular motion, it will produce centripetal acceleration. Okay, and centripetal means center seeking. So as long as you move in a circular motion, right, there will be centripetal acceleration towards the center. Okay, so let's say you have an object moving in a circular motion, you will have um, centripetal acceleration toward the center. Okay, so this will be AC. Right. So velocity, as you all know, is equals to distance over time. Okay, and for a circle, all right, the distance traveled by an object when it moves in a circle is equals to the circumference. Okay, and the circumference usually or can be calculated as 2 pi r. Kan, circumference of a circle is equals to 2 pi r, and time, all right, for an object to rotate in one cycle is equals to a period. Okay, so V can be write as 2 pi r over period. All right, or the period itself can be written as 2 pi r over V. Okay, so if you want to calculate a period of a circular motion, right, you can use this equation 2 pi r over V. Right, and then this equation can later be rearranged into this, right, 2 pi over t, which equals to V over R. Right, so V over R or 2 pi over t ni is equals to omega, where this omega is known as angular speed. Okay, angular speed, all right, which means how fast is the angle change, right? Because an object, when it move in the circle, the angle of the object will change, kan? Let's say we have an object, let's say from here. Okay, so it has this theta. Okay, so let's say this is the theta. All right. So as it move in this motion, okay, let's say until here, then it will have a second theta, which is this one. Okay, so as it move from, let's say this is point A to point B, all right, so theta change. Okay, from theta, so I just change this position as here lah. So this is theta, all right, and then this is theta prime. So from as the object moving from A to B, its angle change, right, from theta, the big angle, into theta prime, the smaller one. Okay, so how fast is this angle changes, right, is called angular speed. Okay, so angular speed is equals to V over R, right? And we can define tangential speed. Okay, so I forgot to put a letter T there. Okay, so tangential speed is equals to R omega. Okay, so tangential speed basically is the normal speed lah. Okay, the normal acceleration. Okay, so since we are now talking in terms of circular motion, so it is wise to differentiate, okay, speed, or to emphasize it more, right, as a linear motion, okay, to call it as tangential speed. Okay, where tangential speed is usually in terms of circular motion, it is this one. Okay, or maybe I better change it into different color. Okay, so this is tangential speed Vt. Okay, so Vt is equals to R omega. Okay, and since our centripetal acceleration just now, okay, centripetal acceleration just now is equals to V square over R, okay, and V equals to R omega. So we can rewrite centripetal acceleration just now as R omega square, where we put this equation into V just now, V square over R. So we can have another equation of centripetal acceleration as R omega square. Okay, so let's see how we use this in example. All right, example 4.6, the centripetal acceleration of the Earth. What is the centripetal acceleration of the Earth as it moves in its orbit around the Sun? Okay, so the question asking for centripetal acceleration, where it is equals to V square over r. Alright, and v is equals to 2 pi r over t, right? We have defined just now. Okay, so 2 pi r over t square over r, right? Which then equals to 4 pi square r over t square. Alright, so we have the radius of the sun, sorry, radius of the orbit of the earth, alright, surrounding sun. Considering that the orbit is a perfect circle, right? And then the period it moves, right? Earth moves around the sun around 1 year, right? So period equals to 1 year. Then we can put all the values. So we have um, centripetal acceleration equals to 5.93 times 10 to the power of negative 3. Okay, so this centripetal acceleration is actually the gravity of our Earth binding to the Sun. Okay, so that's why our Earth is always orbiting around the Sun, because we are attracted by this acceleration. Okay, the centripetal acceleration. So it is actually a rahmah lah, right? Because without this acceleration, our Earth will not be on its orbit, so it will move freely and might be, collide with asteroids. Okay, right. Next question. What is the angular speed of the Earth in its orbit around the Sun? Okay, so angular speed just now is equals to 2 pi over period. Okay, 2 pi over t. So our period is 1 year. All right, and so okay, so we put in the value. So we have angular speed equals to 1.99 times 10 to the power of negative 7. Okay, so please try this example, this exercise. You can pause the video and try this exercise. Okay, next we proceed to tangential and radial acceleration. Right, so basically in a circular motion, okay, so, as we have discussed just now, we will have a centripetal acceleration, okay, where its centripetal acceleration will be directed toward the center, okay, which in this case were denoted as a radial acceleration. Okay, basically this is the centripetal acceleration that we have discussed just now, right? Which produced due to the change in velocity's direction, right? So as if let's say the object is moving in a constant speed, all right? So the direction of its velocity or speed changes, then we will have centripetal acceleration, or in this example, all right, it's called as radial acceleration, which is always toward the center. And let's say the object A ni tadi, alright, the object is accelerating, katakan, okay, katakan it is accelerating, so it will produce a normal acceleration, okay, or in this chapter we call as tangential acceleration. Okay, so the object now will have two acceleration. Okay, so one is the centripetal acceleration, okay, and another one is the tangential or the normal acceleration. Okay, so since it has two acceleration, okay, so it will have a resultant acceleration, okay, where it resultant is equals to a lah, okay, where a can be defined as ar or ac, okay, plus with at. All right, and since acceleration or the normal acceleration, which is the tangential acceleration ni, is equals to dv dt, okay, and our radial acceleration, okay, which is the centripetal acceleration, is defined as v square over r, all right, Okay, and the magnitude of the acceleration, since we have now two acceleration, AR and AT. Okay, so basically we can find, or we can define the magnitude of A by using theorem Pythagoras. Okay, since this will produce a triangle, right? So A can be defined by using theorem Pythagoras, which equals to AR square plus AT square. Okay, so let's see how we apply this in next example. Right, example 4.7, over the rise. Right, a car leave a stop sign and exhibit a constant acceleration of 0.3 meter per second square parallel to the roadway. The car passes over a rise in the roadway such that the top of the rise is shaped like an arc of a circle of radius 500 meter. The moment the car is at the top of its rise, its velocity vector is horizontal and has a magnitude of 6 meter per second. What are the magnitude and direction of the total acceleration vector for the car at this instant? Okay, so the first question asking for the magnitude and direction of the total acceleration. Okay, so to have a total acceleration, we need to find both acceleration lah. Okay, tangential acceleration and also centripetal acceleration. Okay, and centripetal acceleration is given, is already given, right? Which is equals to 0.3. So now we need to find the centripetal acceleration lah. Okay, so centripetal acceleration is equals to v square over r, right? Which is equals to 0.072 meter per second, right? And then we can find the total acceleration, the magnitude of total acceleration by using theorem Pythagoras, where it is equals to AR square plus AT square. Okay, so negatively is just the direction lah, so we can ignore it. Right, so from here then we have total acceleration equals to 0.309 meter per second. Okay, and we can draw the vector of these three acceleration as this one. Alright, so from here we can define phi, okay, the angle of the total acceleration just now, right? And phi is equals to tangent inverse opposite over adjacent, where our opposite is a centripetal acceleration, right? And then adjacent is AT lah. Okay, so put these two values, right? Then we have 13.5 degrees or negative 13.5 downward. Okay, right. So again, if you have questions, please let me know. Okay, but if you don't have any question, then you can try the exercise, this one. Okay, so I'll stop the video here. Okay, again, please let me know if you have any question. Okay, thank you. Assalamualaikum.